Hello, everybody. My name is Mohammed, and those are my teammates.
Sasha?
And Nasser.
Yeah. So our final project is the water level control tank. Basically, our final project is a device that measures and control the level of water on any place, like a dam or swimming pool. Our device works in three cases. The first case, when the water tank is empty, and the second case, when is it filling on, and the third case, when is it full. And Sasha will go deeper and explain it, how it's working. Sasha?
So we have a high-level sensor and low-level sensor inside the storage tank, and water drains out lower, the pump will run it automatically. And we use a representative of those sensors as an LED light. So high-level sensor we represent as a yellow LED, low-level sensor we use it as red LED lights, and pumping for the green LED lights on. And since we don't have the water sensor, we use it as a phototransistor instead. So our phototransistor sensor turns on, since the water, it will be triggers the LED lights turn on and off. And an input goes to the microchip controller, and output will be the through 3 LED lights. If the yellow LED light sensors on, it means high level water and there's no action required. If red LED lights turn it on, it means the low level of water. Therefore, it triggers to turn on the pump for green LED lights turns on.
The function of the circuit is as shown in the next slide, but I will explain. It's a simple circuit which amplified the signal obtained from the phototransistor, and this sensor will trigger the microchip controller, and we have a potentiometer to adjust the sensitivity of the phototransistor. We have phototransistor which act like the sensor or the main sensor, and the potentiometer I mentioned before to adjust the sensitivity of the phototransistor. We have an IC comparator to amplify the signal from the sensor and to introduce it or send it to the photo or to the microchip controller. The hardware component we used on our project is RadioShack Electronic Learning Lab, and we have some part installed on that board, which is the phototransistor and the potentiometer and the LED. We have two transistors. We use two transistors, NPN and BNB transistors, and resistors as shown, and the operational amplifier, which is 339N. And of course, our microchip controller PLC 224F Curiosity Development Port. This is the actual connection of the circuit. On the left side, we have the microchip controller, and on the right side, we have the phototransistor, which send the signal to the circuit I explained to magnify the signal and send it to the microchip controller to make a decision to turn on the motor or to turn it off, or to turn on an indicator that the tank is full or empty.
So here's our system for the software and hardware. So when we use the PIC24 Curiosity Development, we have to use the software for the MPLAB, and the following three shown as the download softwares. Once we build up the standalone project grid view, and we used as a pin model for the 9 and 10, and we also use it as the switch button for the 9. So we modified the code here for the first one, but it can be used as a second way too. But first one is for LED lights on, and when we press it, it will turn on off. The following picture shows this is the LED light without the push button, and then this is the push button, the LED lights is off.
And here is a similar method that we used in real life, like the toilet tank or the water heater. They both work the mechanical movement of the water. And the purpose of our device is to increase the quality of the work and to reduce the risk and the mistake made by humans. And thank you so much for listening.